Dear students, welcome to the today's chemistry class. We are discussing some P block elements. Under this chapter, we are discussing group 13 elements. In the last class, we discussed oxidation state of group 13 elements and the trends in chemical reactivity. Let us discuss now chemical properties. Chemical properties of group 13 elements. So means how group 13 elements reacts with air, reacts with acids and bases, and how group 13 elements reacts with halogens. Let us discuss. The first one is reactivity towards air. Reactivity of group 13 elements with air. See here, boron is very hard non-metal, so that in crystalline form boron does not react with air. Boron in crystalline solid form does not react with air. But in amorphous form, powdered form, it combines with air to form boron trioxide, and it combines with the nitrogen of air to form boron nitride. Boron in crystalline solid form does not react with air, but in powdered form, so this powdered boron, reacts with air to form B2O3, boron trioxide, and boron nitride, Bn means boron nitride. So that is B, 2B plus 3O2 is raised to 2B2O3, 4B plus 3O2, B2O3 boron trioxide, and B plus N2 forming 2Bn boron nitride. So this boron is a typical hard non-metal. In the crystalline solid form, it does not react with the air, but in powdered form, it reacts with the oxygen of air to form boron trioxide, B2O3, and boron in powdered form reacts with the nitrogen of air to form boron nitride. And this B2O3 boron trioxide, B2O3 is acidic oxide. It combines with basic metal oxides to form metal borates. So it is B2O3 is acidic. B2O3 boron trioxide is acidic oxide. So that combines with basic metal oxides to form metal borates. Basic metal oxides to form metal borates. Boron is a non-metal and its oxide is acidic in nature. It combines with the basic metal oxide to form the metal borates. Aluminium does not react with air because a thin oxide film, a thin oxide layer is formed on the surface of aluminium, which prevents from the attack of oxygen. But powdered aluminium, so that is aluminium forms a thin oxide layer on its surface. Formation of a thin oxide layer on the surface of aluminium prevents from the further attack of the oxygen, so that powdered aluminium reacts with air to form aluminium trioxide. Powdered aluminium reacts with oxygen, reacts with air to form Al2O3 and aluminium nitride, Al means aluminium nitride. So like this, Al plus 3O2 gives rise to Al2O3. Aluminium plus N2 gives rise to Aln, aluminium nitride. And here aluminium trioxide Al2O3 is amphoteric oxide. Both basic oxide and acidic oxide. Amphoteric oxide. So Al2O3 is amphoteric oxide because it acts as both acidic oxide as well as a basic oxide. And next, other elements, gallium, indium, thallium, combines with E plus O2 to form E2O3. So that means where E here is gallium, indium, thallium. So it means gallium trioxide, indium trioxide and thallium trioxide. And once again Ga2O3, gallium trioxide is also amphoteric in nature. Indium, Il2O3, Al2O3 are purely metal oxides, hence they are basic oxides. And all these elements, gallium, indium, thallium, aluminum or boron, anything, combines with nitrogen to form nitrides of the formula En. So that is where E is aluminum nitride, indium nitride, gallium nitride, thallium nitrides are formed. Okay, next. Second one is reactivity with reaction or reactivity with acids and bases. Acids and bases. Alkalis. Reaction with dilute acids and dilute alkalis. Base is also called as alkali. Boron does not react with acid and base even at moderate temperatures. Boron does not react with acids and bases even at moderate temperatures. So boron does not react with acids and bases even at modern temperatures. But aluminium reacts with HCl and NaOH to form AlCl3 and sodium aluminate. That is aluminium reacts with HCl, hydrochloric acid, aqueous hydrochloric acid to form AlCl3 with the release of hydrogen gas. Aluminium dissolves in dilute HCl to form aluminium trichloride with the liberation of dihydrogen gas. Aluminium also reacts with NaOH base, dilute solution of NaOH, aqueous NaOH to form 2NaAlOH with the release of 3H2 gas and 6H2 gas. So that means sodium aluminate 2NaAlOH4 means sodium aluminate. So that means tetra hydroxo sodium tetra hydroxo aluminate. Sodium tetra hydroxo aluminate. So the compound name is sodium tetra hydroxo aluminate. This is a complex. So like this, boron does not react with acids and base. Aluminium dissolves in both acids and the bases. Next, third one is reaction with halogens. Reaction with halogens. So here E group 13 element E is nothing but element reacts with halogens to form trihalides of the formula EX3 trihalides halides of the formula EX3 except TLX3, thallium X3. So here E means group 13 element. E is nothing but group 13 element. So if it is a boron and XCl, BCl3, if it is aluminium, E is aluminium, X is Cl2, so then aluminium trichloride, gallium plus Cl, gallium chloride, so like this. So X, F, Cl, Br and iodine. So that group 13 elements reacts with halogens readily to form trihalides, trichlorides, tribromides, triiodides, trifluorides, etc. except TLX3, gallium halide. Next, anomalous behavior, anomalous behavior of boron, anomalous behavior of boron, anomalous behavior of boron. So here boron is entirely different from other members of group 13. Then why? What are the reasons why boron shows anomalous behavior over other elements of the same group? Because reasons. First one, small size, due to small size, and due to small size. Next, melting point or boiling point, very high, melting point and boiling point is very high. Hard non-metal, next, maximum covalency, maximum coordination number is 4. Maximum covalency, coordination number is 4. Maximum covalency is 4 due to non-availability of d orbitals. D orbitals are not available in boron, hence it cannot expand its octet structure. So that means it cannot expand its octet structure. Maximum covalency 4. But other elements like aluminium, gallium, indium, thallium, they have d orbitals also. Hence they can expand their octet structure beyond 6. They have more than 6 covalency. Aluminium has more than 6 covalency because of availability of d orbitals. But in boron, so no availability of d orbitals. And next, boron cannot form BF6 3 minus complex. BF6 3 minus complex. Boron cannot form BF6 3 minus complex. this is due to maximum covalency of boron is only 4. It cannot expand its octet structure. It cannot expand its octet structure. ಇದೊಂದು ಸ್ಟ್ಯಾಂಡರ್ಡ್ 1 mark question, give reason type question ಕೇಳಬಹುದು. Boron cannot form BF6 3 minus complex, give reason ಅಂತ ಈ ತರ ಕೇಳಿದಾಗ ಆನ್ಸರ್ because boron maximum covalency is 4, it cannot expand its octet structure. That is the answer. So fifth point here, reason, fourth one, boron cannot form BF6 3 minus complex, give reason andre because boron has maximum covalency 4, it cannot expand in the octet structure, so that BF6 3 minus complex is not possible. But in the case of aluminum, AlF6 3 minus complex is possible, but aluminum forms AlF6 3 minus complex. This is because in aluminum d orbitals also available, hence aluminum can expand its octet structure. Means covalency is greater than 6 for aluminum. Hence aluminum has ability to form AlF6 3 minus complex. So these are the anomalous behavior of boron, reasons for anomalous behavior of boron. And boron also, once again, boron Lewis acid, already boron chlorides, boron fluorides acts as a Lewis acids because boron is electron deficient. It accepts electron from another substance to complete its octet structure. And so here is one concept question. Around the bottles of aluminum chloride, white fumes are appeared. Give reason. Around the bottles of AlCl3, white fumes are formed. Give reason. ಅಂದ್ರೆ ಅಲ್ಯೂಮಿನಿಯಂ ಕ್ಲೋರೈಡ್ ಯಾವುದಾದ್ರೂ ಒಂದು ಬಾಟ್ಲಲ್ಲಿ ಇಟ್ಟರೆ ಅರೌಂಡ್ ದಿ ಬಾಟಲ್, ಆ ಅಲ್ಯೂಮಿನಿಯಂ ಕ್ಲೋರೈಡ್ ಇರ್ತಕ್ಕಂಥ ಬಾಟಲ್ ಸುತ್ತಲೂ ಕೂಡ, ರಿಯೇಜೆಂಟ್ ಬಾಟಲ್ ಸುತ್ತಲೂ ವೈಟ್ ಫ್ಯೂಮ್ಸ್ ಬರ್ತಾ ಇರುತ್ತೆ. ಯಾಕೆ ಅಂತಂದರೆ ಅಲ್ಯೂಮಿನಿಯಂ ಕ್ಲೋರೈಡ್, ಬಿಕಾಸ್ ಅಲ್ಯೂಮಿನಿಯಂ ಕ್ಲೋರೈಡ್ ಈಸಿಲಿ ಕ್ಯಾಚಸ್ ಮಾಯಿಶ್ಚರ್ and get hydrolyzed. Yes, because of hydrolysis, HCl gas is liberated. So AlCl3 plus H2O to form AlOH thrice plus HCl gas. The HCl gas. So that means aluminum chloride around the bottles of aluminum chloride, white fumes are observed. This is because aluminum chloride easily catches moisture of atmosphere and hydrolysis takes place to form aluminum trioxide and HCl, hydrochloric acid. Because of this reason, around the bottles of aluminum chloride, white fumes are observed.